In this example, we want to evaluate the definite integral from 0 to 1 of x times e raised to the 4x squared plus 3 dx. Here we're going to use a substitution, and we're going to start by letting u be 4x squared plus 3, the exponent of our exponential function in the integrand. The derivative of that will be 8x dx. And we see that we have x dx in our integral, and so we're going to divide both sides of this by 8, so that du over 8 is equal to x dx, and that we can substitute directly into our integral. Because we have a definite integral here, we need to also convert our limits of integration. And so when x is equal to 0, we use our equation for u to determine the corresponding value of u. So u here will be 4 times 0 squared plus 3, and that simplifies to u equals 3. And for our upper limit of integration, we have x equals 1. That gives us the value of u equals 4 times 1 squared plus 3. That's u is going to be 4 plus 3, or u equal to 7. Now that we have all of our values here, we can substitute them all into the integral and obtain an integral in terms of u. So here we have our integral. It's going to go from u equals 3 to u equals 7, our new limits of integration in terms of u. We're going to have e to the u. That's our e to the 4x squared plus 3. And the leftover part is x dx, which we saw is du over 8. And so we can bring out the 1/8 constant out front. So this will be 1/8 times the integral 3 to 7 of e to the u du. The antiderivative of e to the u is just e to the u. So we have 1/8 e to the u evaluated from 3 to 7. And here we just simply substitute in 7 and 3 for u and subtract. So we end up with e to the 7 over 8 minus e to the 3rd power over 8. And this is our value for our integral, e to the 7th divided by 8 minus e cubed divided by 8. Of course, if we wanted to, since we have a common denominator here, we can simplify this into one fraction as e to the 7th minus e to the 3rd all over 8.